Hey there, and welcome back to the Code Wrinkles channel. And today we actually start a new series. It's this web API with clean architecture and CQRS. Before we really get going, it's really from scratch. As you can see here on the screen, I just have a blank solution. I also have a GitHub repository for that, so if you want to follow along, just head to the description and there is a link to the GitHub repository. So you can then, after each stream, I will push all the changes that we do during the stream. And you can then, maybe clone it, fork it, do whatever you want with it. Now, the idea is that I really just want to share with you why or how I came to the conclusion to actually do the stream. So if you have followed me, I guess around 9 months back, I was doing like a series on creating a social network with domain-driven design. However, also due to maybe lack of viewership, I really had for a while to quit that series. Also, that whole concept of domain-driven design here for this live stream, I think it was a little bit too much. But still, there were some people that were requesting that this series should be continued. So I have thought about that and how it could be continued. And I came to the conclusion that, well, I have a very big problem. I really hate front-end. And of course, I'm also a full-stack developer, so on my day-to-day work, I have to also do front-end stuff. I work with Angular a lot. I work with React a little bit less. Recently, I do a lot of Razor views, for instance, unfortunately. So I also have to do front-end, but I really hate it. So I was thinking, okay, let's do this series, but I would really concentrate on what's also fun for me. So I was thinking, okay, let's create this idea of social network. Like, let's create an API for something like Facebook, for instance. And then if somebody from the community or from you, or if you have friends, if they maybe want to do the front end part of it and maybe also on stream, I would be more than glad to host it. So what we will build here is a web API from scratch. So we'll tackle a lot of things, like it should be really usable. We would have versions, we will implement authorization, we will implement authentication, we will work with JOT tokens, we'll actually prepare everything as if it would be a production ready application. And that's at least my idea of doing that. So I will just start coding it the way that I would start an API from scratch right now for a real production scenario. And I would emphasize the way I would start it right now, because, well, as a software developer, you always learn new things, you have new ideas and try out new ideas. And probably in 8 months, 1 year, 2 years from now, if I would have to start an API from scratch, probably I would do some things differently. However, what we'll use is .NET 6. We will not use the minimal API because there are several drawbacks to it from my point of view. So we'll use the regular controller-based approach, but we'll use a clean architecture and we'll also use CQRS. So because I think really that this is probably the best way to actually create an application that is easy to maintain. Otherwise, if you just use services and repositories and things like that, everything will get clunky, everything will grow very, very fast. And at the end, it's very, very hard to maintain. And you have to do a lot of refactoring at a certain point. So I would really just like to avoid that. And I would then use this CQRS approach. It won't be a full CQRS approach. We won't have a database for reads and a database for writes. That would be, I would say, an overhead for now. But we'll use this idea of command and queries that we segregate the responsibilities for commands and queries. Okay. So let's then maybe get started. So we have this this blank solution here. And by the way, whenever you want to say something, if you think that I'm doing something wrong or if you have better ideas, then just feel free to really share this in the chat. I would really highly appreciate that. It is that, as said, I will start working on that as if I would do on a real project. However, of course, I can't know everything, and I'm surely not the best .NET developer in the world. So I really expect from this type of series that I would also receive your feedback on how we might do some things differently, or better than I start doing them initially. So just feel free to jump in to get into the discussion, because that's the way that actually I guess all of us will have to learn something from it. So don't be shy and just get engaged. We have the chat for that. Okay, so let's first okay, I like your course a lot. Very good job. Many thanks. Okay, thank you, Eric, very much for your feedback. The other course is really intended for beginners. So the topics that I tackle there and the way that we build the API there is really like something to get started and getting familiar with it. But I'm glad that you also watched this one, because here we'll see how we actually think about problems and how we think about the design of the APIs when it comes, I would say, to a real production ready application. So I guess that might also be useful for you. And this, by the way, is really not a course. It's just live coding sessions, and probably we'll do things wrong. We'll have to refactor things. So it's not something that it's like a course that I already have really thought about each detail in it. So no, it's actually everything on the fly. Good. So let's get started with that. So the first thing that we would have to do is actually set up like a very basic project structure. And we have this blank solution. I always like to start from a blank solution, and let's add a new project, and let's start with the API this time. So our application, or our API, by the way, is called CWK Social. Of course, CWK is, let's call this also API, is an acronym for Code Wrinkles, so the name of this channel, but in order to be shorter, I use it all over the place. Good, so we have this CWK social.api, and let's click here on next. We will use .NET 6, as I said, because that's also some I would say nice, because .NET 6 comes with a fairly different startup model for the application, so we'll have to think about things like keeping the Program.cs file clean and similar stuff. So that's also a nice challenge to have. And I really like to have controllers in this one, so I don't want a minimal API. And of course, I want to have Swagger. So Swagger will actually be our front end. This is the way that we will actually test our application. And even though we will use authentication and authorization, we won't choose anything from here right now, because I really want to do it from scratch when we'll come to implement that. We'll rely on Microsoft ASP.NET Core Identity a lot for handling user registration roles and claims and things like that. But we will surely implement everything from scratch. So I don't want everything to be implemented already by the framework. So I guess that it would be okay to create a new API. So James Best, I was missing you on my previous streams. Thank you also very much for your services video. I just started watching that, but it's very valuable. Which one? Because I guess I have several of them. It's the one with the service lifetimes, and I guess I have one with background services, and then with injecting singleton scoped services into singleton services. And also we talked about services during the last ASP.NET Core for Beginners course. So I'm not sure exactly what you mean, but I'm glad you find it valuable. Okay. Manohit, you are doing a great job. Keep posting videos like this. Thank you very much. It's really nice to hear that that you really find this content useful. Okay, let's look a little bit into what we have here. So I just want to clean everything up. Let's delete everything for now. Let's delete this. Let's also delete this. So everything that we will need is, this is actually the blank project structure that we have. Let's also delete these comments. We don't need them because we really know how to do things. Okay, and let's also delete this one. I want to have this as clean as possible to start off. Okay, and that would be our API layer. So now let's briefly create, but in this video I really will probably more concentrate on setting up the API, but I would like to also add new projects, but in this case there will be class libraries. So that would be CWK domain. So that would be our domain layer, and it's also targeting .NET 6. So let's create that. Also, let's delete this class, we don't really need it. Also, we have our domain layer. Now, the cool thing that that we have when we are using CQRS is that we actually can, or from my point of view, we can get rid of two layers, especially when we are using entity framework. We can get rid of the repository layer, we don't need that anymore, and we can get rid of the services layer that we usually have, in which we inject repositories and then we do a lot of domain logic stuff. So in this CQRS approach with handlers, everything will be actually in the handlers. The domain logic will be pushed in our domain, so we will have a rich domain model. And when we'll have different domain aggregates that kind of would, I don't know, need to collaborate to create something, we will have domain services. But the difference between the domain services, let's say in a domain-driven design approach, and the service layer that we usually have in most of the applications that I have ever seen, is that we won't have any data access structures in our domain. Domain services are purely domain logic. So we just provide, I don't know, a list of posts, a list of users, and we calculate the newsfeed, for instance, or something like that. But in that domain services, there is really no data access at all. It's pure business logic. Okay, so let's create also then this project, and all the handlers and queries and things like that will have in a dedicated layer, which we will call CWK social dot application. So we'll call this application layer. Now, if you're following the clean architecture naming convention, this would be called use cases. But I find the use cases name a little bit counterintuitive, so I prefer this this idea of naming this layer my application layer. And here we'll put all application specific logics, for instance, authorizations or things similar to that. So let's also create this layer. James, could you briefly describe the intent of CQRS? Yeah, sure. We will do that. Just in one moment. Let me also delete this class because we don't need that anymore. And we'll still need another layer for the data access, where we'll put our entity framework DB context. But I'm also thinking about maybe using Dapper later for getting resources. So let's also create a project for that. And probably later when we'll think about, I don't know, maybe sending emails or handling photos or media that we might maybe, I don't know, have on an Azure blob or something similar to that, we'll probably also have a dedicated infrastructure layer. But for now, we'll just create it if we will need it. But for now, I'm sure that we will need the data access layer. So let's just do that. So once again, it will be a class library. It will be social.dal, so data access. And that's that should be it. So we have also created that one. So coming back to your question, James, as you were asking for CQRS, let me just set up a little bit here, because I would like to use the whiteboard. Okay. And I'm really not exactly sure how to do that, but yeah, let's start with this this basic concept. So let's maybe assume that this is my web server, okay? And here, when we talk about web application, actually, if we think about all the possible requests that we actually get in our applications, now they are, I would say, if we would abstract a little bit and think generally, so what exactly do we have as requests? I would say that we have two types of requests, okay? And the types is, first we'll have, for instance, get request, and we'll have then maybe post requests. And I say here post, but if we think generally here, basically, in a very conceptual way, these are things that actually do different stuff with our application. So usually when we have these gets, we just want to get data, to read data from the server, but we are actually not changing state of the data. So we are not changing the state of the server. Now, when we have these post requests, or put, or delete, or patch, what happens is that we are actually changing data. So we are changing with this type of request, we are changing the state of the application. Now, of course, when we think about, let's say, a solid system design, it would actually mean that we would actually have to treat this type of requests differently. Also, maybe from security perspective, but also from a business logic perspective. Because, for instance, for GET requests, we wouldn't have to do a lot of validations. If the consumer wants some data, here's the data, you can get it. But if the consumer wants to change the state of our data, well, then we have to be more careful than that. And that's why we conceptually can actually categorize these two types of different actions. So one that actually just requests data, and one that actually changes data or changes the state of the server. We could conceptualize this actually in two things. For GET, we would call this a query. So in this case, a query, it means that it's actually executed when we have GET requests, and it's all only for getting data out of the server, but without changing anything. And then we have this, and this would be then a command. And once again, this is not only the case for post request. I just mentioned post here as general, but it's a matter for post, put, patch, and delete. So each type of request that actually changes data on our server or the data of our application. Now, the idea is, okay, that this request comes in, it's either a GET or either a post. So it means that for our application, it's either a query and it's either a command. Now, the whole idea is that we actually, let's say, segregate the responsibility of handling this. And the way we actually do this is, okay, this query will then enter our server in our controller, and then our controller would have to perform some job. Now, the idea is that what we would actually do here is that, well, we have here maybe the query. Let's just place a Q here. Then this query will be handled by a handler. Let's just call this age. And then that handler will perform all the needed query logic or whatever it needs to do, and it will actually get a response. And the response is actually that the part that would actually be sent back to the requester. And then if we have a further GET request, then we have exactly the same pattern. Now, if we have commands, then we have once again they arrive here, and then we have exactly this type of similar logic, only that for our system, in this case, we'll consider this as a command that comes in. And here on commands, we will have probably to treat them, as said, differently, do some more validation, be more careful about things that happen here. We also, when we executing commands or changing the state of the application, we have to really be careful that that command doesn't put the application on an invalid state. But the concept is that we will have still a command, we still have a handler for the command. In this case, it would be a command handler, and then ultimately we'll also have a response. And that response is actually, could be if we return a resource, but it could be something like, okay, we have successfully executed your command, and that's basically it. And as you can see here, this idea is that we really split actually, and we segregate. We have different logic for queries, and we have different logic for commands. And this is actually what CQRS means. Command query response segregation. So it's actually this type of thing. Now, there is one thing that we will have still to take into consideration, like from an ASP.NET Core perspective, I would say is, okay, when a request comes in, okay, we can construct a query in the controller, but how we actually know exactly what handler do we need and what services that exact handler means and or needs. And for this, we will actually be using a library which is very, very nice, and I guess everybody's using it, which is the mediator library. And that mediator library kind of like implements the mediator pattern. But before we go to the mediator pattern, when it comes to CQRS, there is still one other thing that we would have to take into consideration. And let's maybe create a new whiteboard, okay? So we have, and here we actually will have this this whole concepts a little bit different. So we have here, let's have them vertically. So we have here a query. That query will be executed by a handler, or the handler will actually, that contains all the application logic. And then ultimately it will also generate a response. But actually, I don't want to concentrate right now on the response. The idea is that, where is the eraser? So we won't concentrate right now on the response. But what I would also like to show that in a full CQRS approach, so a full command query and response segregation, also an important part would be actually what our database actually is, because here, let's try to actually, and that would be our database, DB. So handlers and queries will then probably use this database to retrieve information. Then we would have here on the other side, maybe we have this concept of a command, and then that command would also be executed by a handler. Okay, and then the whole thing is that this handler, or the commands, I say during commands, we will change the state of the application. And usually in a full CQRS approach, you would have a totally different database for writes. So this is a read database, and this is a write database. Okay, just want to erase that. Okay, so that would be a write database. Okay, so the idea is that, as said, in a full CQRS approach, queries will always use a read database to get the data, and commands will ultimately use a different database to actually write that data. And then we would have to have here either some service that does, let's say, a sync between the databases, or we can have maybe triggers here on this database that would actually insert new things in database when they are changed, and things similar to that. But as said, for larger systems, that is probably vital, because otherwise the database, if you are using only one database, as we will actually use, the problem is that if you're using only one, let's have this DB, and let's say that everybody is using it, so you segregate here between responsibilities, but as long as you have the same database, actually this becomes, or this could become, a bottleneck. And this whole idea of command and query and response segregation should also optimize reads and writes from the database, and give your application a boost in performance because of that one. Because usually writes take a longer time, reads actually are usually faster, and in order to actually not so in order for reads not to be affected by writes and vice versa, we should regularly use two databases. But this being said, that's quite it. That's all about this idea of CQRS. It's actually nothing more than that. How is a handler different than a method that handles a web API post or get method? A handler is actually exactly that. It's just a method that would actually get executed, but we will see that the idea of the handler is that it's actually a standalone class that would encapsulate all the necessary logic that we would actually need. It's just a database aggregation CQRS, where as web API uses one database. I'm not sure I get this last question, James. So in a full CQRS approach, you should have two different databases. But in most of the applications, there are, from a software design and maintainability and readability of the software, there is really a very, very big boost in using this CQRS style, but without two databases. And in fact, what we'll be using in our application will be only one database. So we will not have two different databases. But if you would build a larger system with a high volume of requests, then it might be a good idea to also have two different databases. So that's actually how that is supposed to work. But I would say that we are still doing CQRS as long as we treat queries and commands differently. Now, regarding this question with the handlers, the thing is that let's create a new whiteboard. The thing is that, yeah, in fact, they kind of are very similar, but I guess we will not be able to have actually an answer just now, but I'm sure that during the next live streams, this will become more clearer. The problem is that when you are using everything in your controllers, you actually have methods for a lot of stuff, especially if you have an API with nested resources, which we will have a lot. Your controller will get a lot of methods. This means that if you wouldn't use handlers, you would have to inject in the controller a lot of services, because one controller action might use 2 services, the next one might use another 3 services, another would use another 4, and ultimately our controller will get very crowded with a lot of with a lot of services and a lot of logic. And the whole concept is here to actually take everything and make it as thin as possible. So the whole concept here is that we would move everything to a handler. So for each action, it's actually from a conceptual perspective that each action, so each really action that happens in your application gets actually its own command or a handler, should it be a query or a command handler. And that handler is only responsible for that specific action. So in that case, you would only, if that action needs, I don't know, maybe 2 services from the DI container, then it will get only these 2 services, and it will contain only the logic that exact handler needs in order to fulfill the request. Now, if for each type of such an action in our application, we will have then a dedicated handler. And ultimately, this will actually make our application cleaner and the code more readable and maintainable. But I guess it's fairly maybe difficult to imagine this right now, as we haven't actually written any code. But we'll surely come to this. So CQRS, 2 databases plus DB-Sync, and Web API equals 1 database. No, actually the Web API, we have only one Web API. But as said, we have this handler. A handler that is a query handler would read from the read database. A handler that is a command handler would actually write to the write database. So we have one API, but each handler knows exactly with which database to interact based on the fact if it is a command handler or a query handler. So that's actually what it is. And to say here, I think understanding how CQRS replaces repository pattern, it kind of does, especially for Entity Framework Core. Now, if we would use, and probably we'll do this at one point, but if we will use this this other very lightweight ORM, which is Dapper, which is very, very cool for queries because it's really easy to use, then maybe you might use a very, very basic repository or a wrapper along the Dapper functionalities in order to really not repeat a lot of code. But James, I'm sure that once we progress with this API, you will see the advantages of using this type of handlers, because they are really, really isolated, self-contained, only for one specific feature. And the cool thing is that in each handler, we can actually feel free to use whatever we want. For example, in one handler, we can maybe use Entity Framework. In another, we can use nhibernate. In another, we can use Dapper. In another, maybe we use something to talk to Cosmos DB. So by the fact that everything is self-contained in only one handler, you are free to actually use whatever technology you want in each handler. When you are using repositories, you are actually tied to a certain implementation, or you are tied to a certain technology depth or technology choices that were made. And if you want to actually use other technology choices later in the application, it's actually very hard to do that, because you would have to re-implement actually everything. But with handler that are really very small, self-contained pieces of code, you can actually say, okay, from now on, I want to use in our handler something else, and you can totally do that. So it gives you also a lot of more freedom, I would say. Okay, good. I hope that maybe this discussion was useful for you. It's surely nothing that I have planned, but that's the whole concept of these live coding sessions, which are not courses. Is just that we can go wild, we can have a chat here and discuss whatever you want. Probably there might be some things that I don't know, and I will say that I don't know and that I will research. But it's really important. I really like it that you're getting engaged. So I really appreciate that. Good. Let's now maybe start a little bit to also work on our API that we have already. So we have here our domain layer. What I would like to do is just set up a very basic controller with one action that we can then take as a base to actually set up the entire API. And the way I would like to do is as I would do on a team on a real project, where I would probably be the one that would have to actually create the skeleton and the structure of it, so that other developers might use it and know exactly where to place where, or what to place where. So in this case, we'll actually go through this exact phase of setup that I would normally do for a regular project, I'd say. So the first thing that I would do in this case would be that probably in my domain layer, I would then just create here a new folder. I would call them models. And at this stage, I really wouldn't concentrate a lot of the domain layer itself, because what I would like to do is just have here, and as we will build a social network API, so we'll try to actually implement all the Facebook functionality in our API. Everything's around posts. So let's have a model that is kind of like a post, but it's not internal because we want to use it publicly. So it would be a public class, and let's have a public int, though we might use string here, but we can change that later when we'll introduce the database. And the reason why I might use string is actually that I would probably want to use a GUID to string. And the reason for that is very important. And actually, when you're doing just regular tutorials or side projects, you mostly never think about that. But when you're creating a real application, and at least, of course, that will not be the case for this one, but as I said, I would like to think about it as if it would be a production application. And if I would have to build right now a social network that is similar to Facebook, and I would assume that it would have, I don't know, maybe half of the load actually that Facebook has. And the problem is that if you would use ints, for instance, for posts, you might probably within one single day or less get to the int max value. So that would be a huge problem, of course. And in that case, I would probably use to like GUIDs as identifiers for posts, because GUIDs, well, you have probabilities, I think, 1 in tens of billions of GUID created that you get two that are the same. So, and you can, have a lot. But for now, we'll just have an int, and I will have here public string, and I will say here content or text, because we might have some media content later. But that's actually everything for now. And what I would like to do is to use this as said, as a very basic setup to get here already to our API and create a controller for that with one action that would help me actually to do everything. Are there performance issues with GUIDs as IDs? They still are indexed, so I'm really not a SQL expert at all. But I really don't think that we have real performance troubles here. Um, I mean, even at Facebook, they are using GUIDs. At Microsoft, they are using GUIDs as well a lot as identifiers. So I really don't know what to say here. I don't have a lot of experience with SQL, to be honest. Okay, so let's create here a controller. It is not something like a course, so we might actually learn something. Okay, Bogdan, thank you very much for this one. I well hope that also from the courses that I do, people might learn something. But thank you very much for the feedback. But I don't want to create a controller. I just want to create a regular class. I always hate to create directly a controller or things similar to that. So let's have this class and post controller. Okay, so let's make this a controller, and we make this a controller by simply saying here controller base. And here, once again, there is a lot of discussions. Should we actually inherit our controllers from controller base, or should we inherit our controllers from controller? Now, the main difference between controller and controller base is that controller base is actually a bare minimum of a controller. So it mostly doesn't have view support. But if we inherit from controller, then that actually has also view support. And well, I guess that's also a thing of choice here. I most of the times use here controller also maybe because I accustomed to do that. So not really that I have a strong opinion on that, but I just wanted, well, to really share with you which would be the main difference between this type of controller and controller base. So as said, I usually use just the controller. And if you say that it's wrong, well, it might be, but I don't think that it's really wrong. And if you, for any type of reason, you would just like to, well, return a view or something from a controller, then you should be able to do that without needing to change the controller base to controller, and then you have all the controllers inheriting from controller base and view from controller. And I don't know, for me this it kind of like messes up everything. So I just prefer to have controller, because if I would need to also return some views, that I could do that. So yeah, that's why I'm using this controller. And then of course we need also to say here that this is an API controller, this attribute, which will also add some very neat controller functionality to our endpoint. And then we would have to also specify a route here, a route attribute, and here the route for our controller. For now, let's make it just very simple. Stick to the convention, is just the controller. Now I won't even create a constructor for now. I just want to have a method for retrieving something. Public. It would be, for now it won't be task, it would simply return an I action result of post maybe, and we'll call this get by ID. Okay, adding a reference to our domain layer. Of course, we will change that later, because we will talk a lot about API contracts and what they are, because this is how I also would regularly do it in a real API. But for now, I just want to set up a very basic skeleton. So get by ID. That would be, I would have an int ID here. I would also specify here an HTTP GET. And I know that usually ASP.NET Core, if you don't specify something, it would assume that it is a GET request. But when it comes to also Swagger and other tools that we'll use, they might get confused if really don't specify that. So yeah, we specify that this is a GET, and we also specify here a route. Okay, and the route would be actually controllers /ID. And what is the problem with that? I action result. Did I mistype something? Cannot be used with the type argument. Oh, of course. I'm always accustomed to return a task of action result, and that's why I will. Yeah, well, I use that generic construct, but of course, action result is well self-contained and non-generic, of course. So here we'll just have, for instance, whatever ID comes. We don't really care. We just create a new post. Just maybe create a variable for that, var post equals new post. And I really like a lot Visual Studio 2022 because it really does a lot of things for you. So it's IntelliSense at the next level, I would say, which is really, really great from my point of view. Okay, so we have this ID here, and we also have some text. Okay, and let's say here text, and for that one, it would be, I don't know, hello world, whatever. So this is what we will return from that, and we'll just return okay. And the post, which is actually cool. Okay, so we have right now a basic controller. Let's run the application, and we should already have Swagger working. So the application already started. I guess it's on the other screen, but no worries, I'll bring it over. This is our Swagger documentation right now. Well, that's the name of our API. We'll change that at the end. We have this post. Let's try it out. Let's specify ID 1 and execute. And we get here back this one with hello world. So we already have a working controller, so that's kind of great. Now, the next thing that I would think about when I'm setting up a new API is versioning. Because sooner or later, you will need versioning in your API. And versioning could be a nightmare, but if you start it from the beginning and think about versioning from the beginning, that would actually be okay and make things much easier. So let's also think about this idea of versioning. And by the way, I just wanted to let you know that if you want to support this channel, as everything's actually for free here, and well, that's a lot of time investment. You have the super chat option where you can actually make a donation by using a custom sticker or an emoji. Also, if you want to do that, then please feel free to do that. That would be very much appreciated. But let's get now back to this whole idea of API versioning. Now, when it comes to API versioning, we'll need to install some packages. So let's where is it? Manage NuGet packages. So that should be it. Okay. And yeah, browse, but I don't want the Telerik feed. I just want this one. Okay, so one of the first package that we would need to install would be I don't know, it's called Microsoft ASP.NET Core MVC versioning. And actually, these are the two packages that we'd actually need to install. And these packages kind of like will help us to really version our API. Okay, so we'll also need this API Explorer. Let's install that as well. So it's Microsoft ASP.NET Core MVC versioning and Microsoft ASP.NET Core MVC versioning API Explorer. I think use cases is a good naming of the app layer as well. Yeah, Bogdan, I really don't disagree with you. So yeah, it's a good naming. It's the standard naming in clean architecture. Only that for me, it's like a little bit counterintuitive. So I prefer to have it as an application layer. But the concept is exactly the same. In use cases, you just have application specific logic, and then of course in the application, it's exactly the same. You have some application specific logic. But I don't disagree with you. So if you want to name your layer use cases, then just do it. So, and in most of the .NET projects that I've seen also by others, that they mostly use in the .NET ecosystem the naming of application layer. But as said, if you have a strong opinion on why we should name this layer use cases, then please feel free to elaborate. It would actually be nice for me to hear your take about that. And a shout out to James, who just donated 10 Canadian dollars, I guess. Thank you very, very, very much for that. Good. Okay, so we have installed these packages. So the first part is actually done. But then we will actually have to actually do some other stuff here. So if we go here in our program file, and by the way, this is .NET 6. I'm not sure if you are familiar with .NET 6, but in .NET 6, there are some, I would say, rather substantial changes when it comes to how the startup looks like. So we don't have two different files, the program class and the startup class. We just have one, which is the program. And that's actually very, very cool, I would say, because it's very similar from my point of view, at least, with what we have in Express.js. You just get here a web application builder. On that builder, you configure a lot of stuff, like you can add your services, for instance. That's what we were regularly doing in the configure services method in the startup class. But besides that, you have here properties through which you can actually configure a lot of stuff. If you want to read configuration from additional sources than what ASP.NET Core provides by default, you can simply do that with configuration and then add JSON file or add ini file or whatever other options there are for reading configuration. If you want to set up different things about your environment, you have this iWeb host environment that you can use. If you want to do some host specific configurations, like I don't know, URL and how the host should run, you can do that there. If you want to add or further configure your logging, you can do this via logging. And you can also configure your web host. If you want to change your content root folder or your web root folder, you can actually do that there. So on this builder, we actually have a lot of ways to configure our application before actually the application is built. So it's during this builder, this building process. And ASP.NET Core is actually using here this builder pattern, which is very, very nice for this type of scenarios. But making it short, so in .NET 6, here in this part, so where you do stuff on your builder, it's actually, these are things that you would regularly do, or that you were regularly probably doing in the startup class in configure services. And why I say that is because, at least on the projects that I worked, I never really tweaked with the configuration. Although with the configuration, maybe we have added some custom JSON files, so that might be the case. And you would have to do that in earlier versions of .NET 5 or .NET Core 3.1. You would have to do that in the program class, not in the startup class. But usually, or I would say 80% of the things that you were doing previously in the configure services method, you would do here now on this builder on the services instance. Okay, so that's one thing. And then the other thing is we build the app, and of course, since this was a web application builder, we get back a web application. And on the web application, you actually do all the stuff that you were doing in the configure method of the startup class. So usually just registering middleware, which also happens here. So yeah, Eric, shout out to Eric, who also donated. Thank you very, very much. It's very much appreciated. Okay, so that's actually how this looks like in .NET 6. So yeah, it's quite a change, but I wouldn't say that it's actually too complicated. I guess it's fairly straightforward in some ways. Now, regarding API versioning, a few things that we want to do here is, of course, use the packages that we have installed to actually configure how we actually want to do this API versioning. And I would like to create here some space. So I would have here on the builder, and then of course I would have here on services, and I would have here a method should be called add API versioning. Of course, if I would be also able to type correctly, that would be great. Now, this add API versioning, you can simply just use this method like that, and it would add some defaults. But you can actually provide here a configuration delegate, where you can do then some more specific configuration. And there are a few things that I usually like to do. Not sure if they are really the best, but well, until now, I guess I didn't have major problems, and it turned out that it was okay. But of course, if you have some other ideas, just let me know. So one of the things that I would like is to have then a default version specified. And for that, we have this class API version, which is, I don't want to use here the fully qualified domain or the fully qualified name. So just let me add a reference. Okay, so it would be a new API version, and here you can actually specify a major version, a minor version, and I guess like that. So you could do it like this. So I would say that my default API version right now is version 1, or will be version 1. Now, there is one other very important setting that I would like to set usually when doing versioning, and this is called assume default version when unspecified. So when clients make calls where they don't really specify the version, I don't really like to really return errors or not found or things like that. So I would just prefer to assume the default version. So in this case, if there are calls where the API version is actually not specified, it would actually default to version 1. Kind of if you're doing the versioning in the URL, and probably this is a topic that we'll also discuss, and yeah, maybe we can really have a chat about that when we get at that point, because we have actually different ways of handling versioning. And now the most common way that you see in most APIs, or at least in the ASP.NET world, is that you have your versioning in the URLs. So let me show you what I mean by that. I mean by that you would have, not in the domain layer, but in the controller, you would have here, for instance, something in the controller that would be something like that, like V1 or V2, and things similar to that. Now, I said this is maybe the most popular approach in the .NET ecosystem, I'd say, and we'll also probably use that because, as I said, well, as it's the most popular, but it also, or even if I guess I will use that, or I would use that, because most of the people are accustomed to have it like that. There are some drawbacks, and those drawbacks are more, from my point of view, conceptual drawbacks. Because what happens that as we include this type of things here, this actually goes against the REST principles. Because according to REST, our URI should just identify resources and not API versions, not other things. So I can definitely understand if you're saying that, okay, this would not be an acceptable way. I fully understand that, and I really don't disagree with you. But I said probably we'll also go for this approach. However, there are other ways to actually go about versioning your API. And there are two other very popular ways, besides having this in your URL, is to specify the version as a query string. This kind of, like, also from my point of view, kind of a little bit violates what REST does, and well, you would just have to add a query string with the API version to each call, which, well, could be counterproductive maybe in some cases. But then there is also another version which I tend actually to think it's the best, is to have it in the headers. But in that case, actually, most consumers would have to make sure that they will put in their header a version header for the version of the API that they are actually requesting. And as I said, due to the fact that most folks in the .NET world actually are accustomed to this, and people that would also write the front end for that would probably also be some full stack developers that have things to do with .NET and .NET Core, they would probably be very familiar with that, and less familiar with having the API version as a query or as a header. So that's actually my reasoning behind that, nothing more than that. So in fact, for that, if we go here back to our program class, as I said, we have these different versions actually to actually implement versioning or make sure that consumers put the version in their requests. So one other thing that I would like to do is first we have here a config, and here we say report API versions, and that's actually a very cool thing. What this actually does, to each response actually that you create, it would automatically add a header in which it will tell which are the supported API versions. And this might be very useful if you have, for instance, let's say version 1, version 2, or version 3, and at a certain point version 1 gets deprecated. So for a time version 1 will still work, but it will simply be decommissioned. So this is a way to actually report in each response through this header to your consumers that, hey, if you're using version 1, at a certain point, well, that might not work anymore. So you have just to be careful about that. So that's why I actually like to use that. So that would add really in each response, it would add the supported API versions, which I guess it's a very important information for the consumers of the API. And then there's one other configuration that we can do, and this is the API version reader. And this is actually the part of the configuration that that actually instructs our API versioning package exactly what approach about the versioning do we want actually to go for. And here, for instance, we will have query. How was it? I don't remember everything from scratch. But let's start with the URL segment, because I might need to add some URL segment. How is this called? URL segment. How is this called? API version reader. I guess it should be something like that. Of course, without the 0 here, that was a typo once again. That should be a class. So let's have the new keyword. And let's see, can I add? Yes, I can. I have to add this versioning. I thought I have already added it, but well, it turns out not. Cool. So we have this URL segment API version reader. What actually this does, it says that, hey, when it comes to reading the version or handling this version, I use this approach for having it in the URL. But if you want, you can come here and say, I would say here query string API version reader, and in that case it would by default use the query string to read the API version. So that would be the approach for the query, and then I guess it's something with header API version reader, and that would actually instruct it to use the headers to actually get the version to which or for which the call should be made. And in this case, now I said, so these are the different options that we have, and I guess for now we will go with this URL segment API version reader, because this is what we actually want to do. Okay, so I guess that would be all for the API versioning itself. And now let's actually go back to the controllers and let's create two versions for this post controller. So then in this case, we'll also restructure a little bit. We'll have here under the controllers folder, we'll have a v1 folder, and we'll have, for instance, a v2 folder. Okay, and let's move this post controller in v1. Let's also change the namespace for that, so it's in v1. It should be okay. And we'll also create a new controller. Let's just also copy this over, and let's create a new controller here. new class that would also be post controller. Okay, cool. Guess I'm fairly fine with that. So Bogdan, if you're still watching, I really want to hear about your thought process, why we should use the use case actually term for our layer and not the application. I said I really don't disagree with you, but I just would like to also learn more about your thought process about that. Okay, so we have here the post controller, but we can actually delete everything because we have copied everything over from here. So we just have to change the namespace here to be a v2, and here instead hello world, we just return hello universe. Okay, so that would be fairly it for now. Now there's one other thing that we would have to do here, is that we would have to decorate our controllers with another attribute, and that would be API version. Here in the API version, you would have to provide a string, and I want to have it, this would be version 1, and this API version, and that would be version. Here we have to provide this as a string. So in the configuration, we provided that as integers for major and minor, but here we can actually specify that as a string. You can even override, for instance, for each action. You could, for instance, have here map to version, an attribute, and in this case, for instance, if you would have actions that would actually be the same for v1 or v2, you theoretically could just, for instance, decorate this with also API version 2. So then this controller would support both versions. But if you want this one to say that, if you want to say that only this action actually supports also version 2, or is the same also for version 2, then we can just have this other attribute for versioning. Sorry, that's another typo. So we can have another attribute for versioning, which is map to version. Here, once again, we have to map to version and say that this also maps to version 2. Now, there might be, once again, different approaches, like how do we really want to do that? I really think that the approach that's actually working better and that keeps things straightforward when you start to get a lot of controllers, even if it might seem that you duplicate some actions or things like that. But I really think that, or my experience till now has shown that the approach, or the approach that I think it's easier to understand and maintain when new people get on the project, is to have totally different controllers for different versions. So yeah, that's how I really think about that. So that's why I have this v1 or v2 folders. And once again, there are a lot of folks and projects, also very, very big projects, that are using exactly this approach. There are other projects that are actually having only one controller and specify for each action exactly to which version it actually maps, and they create dedicated version for, or they create dedicated actions for v2 if needed, or v3. But in my opinion, the controller will get very, very messy in this case. So yeah, I strongly like this approach with having actually two folders, so v1, v2, and when we'll have a v3, we'll have a v3 folder, and it would actually go like that. So now let's just remove that, because I just want to keep them separate. And I guess our application should mostly already work. But the problem with API versioning is that theoretically this should actually already be working, so the versioning. But the problem is, most probably, let's take a look here. The problem might be, okay, it's on the other screen, I'll bring it over, no worries. The problem is this. Problem is we have Swagger actually here, and Swagger actually doesn't know exactly, well, where to look for. We have here, we see that we have an error response, and here if we look here, conflicting method path combination get. So Swagger out of the box actually doesn't really understand what happens here, because we have two different versions, and that's maybe the most complicated part of setting up versions, is when you're also using Swagger, because you have to actually instruct in Swagger exactly what it should do, and actually instruct it manually, or instruct it to create different documents for each version, to create different endpoints for each version, and things similar to that. And we will have to actually manually implement that. But before we do this, I really need a break. So we will go on a very short, I guess it will be less than 10 minutes break. And then we'll continue with implementing our versioning. And we still have a lot of things to do with this versioning. I really want to make Swagger work. And my plan is maybe to also look into some refactoring of the program class, because it already, well, it already starts to get ugly. So we might need to find ways to actually extract everything from here in some separate parts. So we look into different techniques and ways to achieve that. Good. So please stand by. I will be back, as said, in around 10 minutes, and we'll continue our work on implementing this versioning, and then maybe cleaning also things up here, so that we could be good to go to continue probably then at some other point. But please stand by. Once again, we will be back, or I will be back in mostly, or at most 10 minutes. And I hope you are still here by the time. Okay, so I'm back. Thank you for standing by. I'm really glad you are still here. By the way, there are also other ways for you if you really think this content is useful, and if you want to support it, just share the content that you think is useful with your colleagues. I don't know, social networks, wherever you might think that there might be somebody interested, and also invite fellow colleagues to subscribe to this channel. So that would be also awesome. So big thank you in advance for that. Okay, so let's then look into how we would actually, or what we still have to actually do to actually get Swagger working with our API versioning. And to do that, we would also have, you see that we have here an add, where is it? Endpoints API Explorer. And that's kind of like a service that that creates a lot of metadata about our API, looking at the controller, at the actions, and things like that. The only problem with that is that it is by default actually not versioned, so it doesn't support different versions. So what we'll do here, we'll actually add, let's add the service before this standard that gets here by default with .NET 6. And here we would have to have here this builder.services, but add versioned API Explorer. Okay, cool. So, and here of course we can actually also provide some configuration, or we can call it config, of course, to be consistent with what we already have. And there's actually two things that we actually need to do. First of all, we'll say here config.group name. And here what we actually have to do is kind of like provide a pattern for the naming. And since we will be using this URL segment versioning, and in this case, I will just copy the pattern, actually. It's this one, because otherwise I'll probably mistype it. And still I did something wrong, because we have here double quotes. So yeah, now that should be good. Now, one other thing that we would have to perform here is actually go here and say config dot. And here we have substitute API version URL. And what this actually does, we'll see that, we'll actually see that now, because we'll go to our controllers. And here, instead of having, for instance, this API v1, we will actually make it dynamic. And what I mean with dynamic is that instead of version, we just provide a v, and then we have a placeholder here. And here we should specify version and API version. And this is how the package would actually look into and replace this with the current version at which we are looking. So that's actually something that would be good to have. Now here, for instance, let me take out this API controller, because I really like to have it at the bottom, and that would be okay, I guess. Good. So we have we have kind of like this setup right now. So that would replace the version. Do you think setting the route inside the HTTP GET attribute is wrong? Actually, not wrong, but the idea is that you set the base route here for the entire controller. So it means that on the GET methods, for instance, or on all the other methods, you just have to specify the segment that follows the base route for the controller. And it actually keeps that really shorter. Because otherwise, especially if you have nested resources, well, then here these strings will actually get very, very big. Still, will also probably, because that's also what I would do in a regular API, just replace these strings and have static classes that would contain all routes for each controller. So it's actually not wrong, but I think it's more readable to have, or to specify the base route for the controller at the controller level, and to specify only the segments that are specific for each action here in the route on the action. So it's not really wrong, but I think, or I see it, this is always also very subjective, but I see that this is easier to read and understand what this action is all about. Instead of having to read everything, you just see that it just gets by ID. So it's not totally wrong, but so it's not wrong, but I just prefer this other approach. It, for me, it seems to be much cleaner. Okay, and what we need to do is actually we can actually just copy this over and go to the V2 controller and yeah, just add this. Now at the V2 I see, oh sorry, I was looking at the wrong spot. We have the API version and we have here the route, and let's just replace this with, once again, the version string, and let's also put the API controller at the bottom. Critically, it really doesn't matter where you put this API controller, but well, it's maybe a matter of OCD. I just like to have it just above the name of the controller, so that's actually all to it. Okay, so we have also added this version to our API controller. So I guess that we are a step forward right now, but probably this will still not 100% work. So let's just run it, because there is one missing step that we would actually need to do, is actually specify Swagger exactly what documents it should create and what endpoints it should create. So if I go here, it's probably still not working. It's working here that I have this v1, which is okay. And if I can try it out, sorry, I have to provide an ID, of course. That's the way I have designed the route, and everything's okay. But we can't really get the second version. So Swagger just creates this one, and it was able to create it because, well, we have this replace URL segment, which replaces, I say, that specific pattern with the current version. So theoretically, we are one step forward, but we are not quite there. So the last thing that we need to do, and maybe that's the trickier one, is we would actually need to specify, for instance, here in the program, to the builder, what exactly it should do. So it should look at all the version, and it would specify that it would need to create a Swagger document for each one of that. And yeah, that's something that we would have to do here. However, problem is that in order to do that, we have to inject a service that actually comes from this version API, which is the IAPI version descriptor provider. Problem is here, the service collection is not built already, and we could theoretically say, for instance, let's go here. We could theoretically say builder.services.build service provider, and to build a provider and then get the required service. But this is not okay, and this is cool because in .NET 6, and I think in .NET 5 or in .NET Core 3.1, you didn't get this warning. But that's actually wrong to do, because that would actually build you two separate service providers, and it would, if you have singleton services, which you probably will have, or even transient, it would actually create more instances of them, because you would have two different providers. Or each time that you would call this build service provider, it will add a new service provider, and that's actually not the correct way to do it. And that was never the correct way to do it, although I see a lot of .NET Core apps that actually do that here and build a service provider and get a required service. But if you are in this scenario where you need to inject something and you can't really do this injection because you are at the stage where you just configure your services, so the application is not built already, this is the place where, well, also according to the Microsoft documentation and to my knowledge, the best way to proceed here is to simply use the options pattern to register an options service that would do everything for you. And you can do that because in that options service you can inject what you actually need. So in this setup stage, we actually then also get to also play with this options pattern. So let's create a folder for that. Call this options, And here in this option, let's create a new class, and let's name this class configure Swagger options. And that would be something like that. Of course, that would be a public class, and in order to really be able to add this as a configuration to the service collection, we actually just have to implement an interface, and that interface would be configuration, and that would be also a generic interface, and we have to specify the configure, or it would be a Swagger gen options, because we need the Swagger generator options to actually set things for Swagger, and use swashbuckle and use I don't have Microsoft extensions configuration abstractions. That's strange. Shouldn't it be by default with ASP.NET Core? Okay, that's find and install latest version. Okay, let's do that. I was thinking that that should already be a part of, but you know, it's not a configuration. I guess I'm a little bit too tired for that. Configuration is of course the ASP.NET Core configuration, and that's not something that we need. That's where we configure our let's say configuration sources, like settings files or environment variables or things like that. But we want here to actually configure options for the service collection. So it's configuration options in this case, and that should already be why it is not. I don't want to it's not configuration, it's configure. Okay, and now yes, that's it. Microsoft extensions options, this is the one that we need. Cool. Okay, so right now we just have to implement the interface. Let's add the method for that, and the only thing that we need to implement is a method configure, where we can specify what we actually need to do. But the why we actually use this options pattern is that in this options pattern we can actually use dependency injection. So I would have here a private read-only, and as I said, the service that I would need from the API version is API version scripter provider. It's just a provider that actually gives you information about the API versions that you currently have. Okay, using Microsoft ASP.NET Core MVC API Explorer. Should this be the correct one, I guess? Yes, I guess it should be the correct one. Cool, so we have this provider. So now what we can do here is we just don't want to throw exceptions. So what we would need to do is here to make a for each, and what we want to do is that for each description of a version API, that would be in provider API version descriptions. Where is it here? What we want to do is, well, we want to generate a Swagger document. So options, because we get these Swagger gen options, this is why it is a generic interface. So options, and then here we have these Swagger configuration methods like Swagger doc. And in this one, we can actually provide a description, and we can say the group name is the name for the document. And what's the problem here with Swagger doc? Let's also look into the chat, but there are no new questions. Microsoft extensions dependency injection, correct? That's okay. Still, there's no okay, yeah, of course, because there is another thing that we have to provide here, and this is an API version. You see that we need to provide an open API info, and as we need to create that for each of of the descriptions that we have, let's do this in a private method. Private, that would return an open API info, and we'll call this create version info. And here we'll just provide the description that we have, which is of type API version description, and that would be you can call it description. I guess that would do it. Of course, we open API info, we should probably add this using. Okay, that's cool. And of course, we don't return anything yet, so that's the problem. So what we actually do here is var, let's say info equals new open API info, and we can actually use here an object initializer for that, and we can specify here two things. Title equals, let's call it here social, and then we would have to provide the version for it, and then that would be version, and you can here use, for instance, description.api version.toString. So that would actually be it. And there is one other thing that I would like to do is that if the version is deprecated, and that's kind of like nice information to have, description.is deprecated, we have this bool. If the version is deprecated, we can mark versions as deprecated in the configuration of at the API versioning if we want. Okay, and here we can, for instance, say here something like info.description, and here we can provide a string and say, for instance, something like this API version has been deprecated. Okay, we are cool with that. So then we can just return info. Let's also type it correctly. Okay, so Bogdan, I see. I think my argument for use cases would be that is more entangled with the actions the domain needs to have meaning. In the end, the action of the user of that system would need to execute. Yeah, probably I'm not that eloquent at this hour too, because we are actually both from Romania, so it's fairly late. But yeah, I think I get your point. So it's kind of like more speaks about the intent of that layer, that it actually handles user actions or practical use cases of that application. Yeah, I agree with you. That's a good reason, totally. Okay, and let's go back here, and also besides the group name, we can just use this create version info. Okay. Well, of course, we have to proceed to provide a description to that method, so that would actually be good right now. So I guess this configure is okay. Now there is one other thing that we would need to do here, and is to go here in the program and actually say here after this version, we can simply say here builder.services. And here, if I'm thinking about how this should actually look like, it's still on services, but configure, it's actually configure options, I guess. Builder services configure options. Why do I have all the errors here? Okay, this configure options is of course generic, and we have to specify here the class where we have created these options. So it would be configure swagger options. Okay, I guess we have to import this namespace for our options folder, and yeah, that actually would do it. here, what also I would like to do here is maybe move this add Swagger gen before these options configurations. Okay, so we also have done that. Now, there is one other thing that we still need to do, and we need to create the endpoints, because this configuration will create the documents itself. So the JSON documents that Swagger actually uses to create that UI. But for the endpoints for Swagger, we of course have to configure some middleware for that. And in the program, we have this use Swagger UI. So in this use Swagger UI, you would have also to specify some options there. Of course, this would also be an object. Okay. And here the application is already built. So we already have an iService collection or an iService provider that's already built. So what does this mean? Okay, shout out also to Bogdan for supporting this this channel and this live stream. Thank you very much. It's very much appreciated. So here we can have some options as well, and here we will also need to get all the version descriptions from actually the same service. So from this iAPI version description provider. But the difference between the step that we have here and the step that we have here is that here we already have a configured and built service provider. So in that case, we can just get a required service where we need it. So we would have here var provider. So we don't need to do any other fancy stuff like creating options or things similar to that, because here we can already require services. So it would be equals app.services. And you see that on the services, we have this get required service, which I assume that you are very familiar, because we can use it in a lot of places when we require services. And in this case, we just need a service which is of type iAPI version description provider. Okay, that's a long name. Hopefully it's correct here. Using Microsoft ASP.NET Core MVC API Explorer, that should be fine. Okay, so this would resolve the service, which is cool. And we can do here something very similar that we have done in our configure options. We have here a for each, and we see that for each description in, and we have here provider.descriptions. Okay, go away. Provider.API version descriptions. Okay, so that's what we actually need. So in this case, we just need to say, hey, for each version that we have, I just want you to create me a new Swagger endpoint. So in that case, it would be options.swagger endpoint. And in this method, we can just provide the name of the endpoint, and that we would actually use string interpolation here. So it would be /swagger, and it would be then description.group name, and then it would be /swagger.json. Okay, that's cool. But besides this string, another thing that we would need to provide here is once again the version of the API, or well, the name for it. So description, we will use the same thing that we used on the other part. So this description.API version.string, and that should now generate me also the Swagger endpoints for that. So I guess, if I'm not wrong, I guess we should be good to go right now. So if we run our application, I would expect that we can navigate through the different versions in Swagger. So let me grab a drink first. So So the viewers that haven't said anything yet. Okay, we get an exception, not object, but oh sorry, didn't manage to really look exactly where we had this exception. Let's take a look. So it's in API version descriptions in our object reference not set to an instance of an object. Okay. Of course. That's cool. I have created a field and you didn't say anything about that. Yeah. Yeah. That's mistakes that happen, I guess, at a certain hour. Sorry, not with underscore. Okay. So this time, I guess it should work. I was about to say the viewers that haven't interacted like yet in this chat. Please just let me know from where you're watching. I would be really glad to know or to get to know my community a little bit better. So don't be shy and use the comments here and just let me know from where you are watching. That would be really appreciated. Thank you very much in advance for that. Okay, so let's run it again, and hopefully this time we won't get any exception. At least, hopefully not on the startup. I guess it works. Yep. So at least we don't have an exception. And let's try this out. So we have here by this default, we have this version 1. And here, if we try it out, let's provide ID 1 and execute. We get hello world, which is what the version 1 of this controller should return. But now we see that we can also choose a version 2 here. And now the URL has changed. You see, we have version 2 here. So if we try it out, once again with ID, and this time should be hello universe. And that's cool. So yeah, I'm fairly glad we have implemented API versioning in a .NET 6 API. And we have also made this API versioning work with Swagger, which is a little bit painful, I have to admit. But yeah, if you just want to use Swagger, then you have to go through this kind of setup. But if you don't have to use Swagger, then, well, all the things that we actually recently did, you can just skip. So you can just take the part for configuring the API versioning, which would be, let me show you, which would be this part only, and just provide versions for your controllers. So if you wouldn't use Swagger, you can just do that, and well, everything would be fine. But with Swagger, well, it takes a little bit more to configure. But however, Swagger is really important, and in most of the projects we kindly use that away. From Pakistan, good vibes. Thank you very much, Amir. I'm really glad you're here. By the way, what's the time in Pakistan right now? Because I'm streaming from Romania, and here it's kind of like 10:42 p.m. I guess it's already next day in Pakistan, probably. It's probably already November 26th, I guess. Thank you very much, Amir. So also the others, please feel free to interact. I would be more than glad to learn more about you. I really want to build here a community, so I really want to get to know each other. 12:42 p.m. in Vancouver. 12:42 p.m. In Vancouver, Canada. That's late, but I'm kind of like intrigued. Shouldn't it be 12:42 a.m. or something like that? Okay. I'm definitely bad with time zones. Thankfully, we have in .NET the Noda time library that could help us to tackle time zones better than the defaults that we have in .NET. Okay, good. So right now we have these kind of versions that work. Thank you very much, James, however, for your input. So we have these versions that work, but there's one other thing that I guess I would like to do. So the problem is, as you might see, and you probably would have this problem, and it's 1:44 p.m. In Denver, US. Okay, and it's 1:45 a.m. Yeah, sorry, I got confused by PM and AM. Yeah, correct. Starting with 12, it's already PM. So it's lunchtime. So enjoy your lunch. Thank you for watching during lunchtime. And in Denver, Andre Tango, thank you very much for watching from Denver, US. It's kind of like, well, similar to Vancouver, Canada. A difference of only 1 hour. Thank you very much for watching from the US. I'm glad to have you here. Okay. So going back to this here, one problem that I often see on projects, on .NET Core projects, is that this, or in most projects, because .NET 6 is quite new, and well, I don't think there are production apps on .NET 6, or maybe if there are, they're probably, I don't know, from Microsoft or other partners that are already using it for quite some time. But the idea is that the startup file usually gets very crowded, because we usually have to register a lot of services, and we usually also have to register maybe some custom middleware too, and this file gets very crowded. And of course in .NET 6 this will be actually ported to the Program.cs file, and it means that we will have this as a very crowded file, and I really want to keep it as clean as possible. And there's a way to do that. I wouldn't say that I have invented it. Actually, there are quite other ways to do that, but I guess the nicest one to do it is maybe to bring a new concept here and think about registrars. So similar to like we have domain registers for the web, we can build our own registers that kind of would be responsible to register a certain subset of services. And if we can group them in logical registers, well, that could be actually very fun to have, because you would have the service registrations in separate files that would be very easy to read. And then the other thing that I think most of the people skip, and that could be really useful, we can actually use the power of reflection to automatically register or to automatically register all the services from all registers in our application with only one single line of code. So Bogdan, I think the URL version reader is the best. It has more intention into it. I fully agree that it has more intention into it, but it kind of like breaks the REST paradigm. So yeah, you always have to wait on actually everything. It's never only black and only white in programming. I know most of the people would think it's mostly black and white, but it's mostly not. Okay, so let's kind of get started with that. Let's build a new folder, and that would take quite a while. And that's actually a similar approach. I'm not sure if you followed my video. I have actually developed a library for the minimal API that brings in the concept of module and self-registering modules. And that's actually something similar that I want to implement here, and it will really help us to keep this file clean. And this approach, you can really port it and use it in all your .NET Core applications, no matter the version. And it will really keep your startup file very clean. And that's quite, I would say, a major benefit. So let's go here and create a new folder. And for this folder, let's call it registers. Okay. And here I would need, I guess I would need two different interfaces, because I would like to have registers that kind of like do stuff on the web application builder in this case. If you would do this in an ASP.NET Core version prior to .NET 6, you would have probably to think about registers for the iService collection or for the configure services method, and registers for the configure method. Here in .NET 6, we think about registers for the web application builder and registers for the web application. So let's create here in this registers folder then two interfaces. So the first one, let's start with it would be an interface, and let's call it I builder, or let's use the full name. We have IntelliSense. We just want to keep the the intent clear, web application builder registrar. So this interface would define a contract for what a registrar on the web application builder should do. Amir has this question. Sorry, I joined just. Are you using clean architecture and CQRS in? I will use clean architecture, and we can see this already from our project structure. We will use actually CQRS, but we are not using the minimal API. It's a regular API in .NET 6, not the minimal one. The difference is that in a regular API, we still have controllers. In the minimal API, we don't have controllers. We just play around with endpoints. But if you want to find more about the minimal APIs and how we can work with them, I have plenty of videos on that. There's a playlist on the channel which is called .NET 6 or .NET 6 and C# 10, something like that. And you will find there are plenty of videos regarding minimal APIs, how to get started with it, how to bring in the concept of modules, maybe also using the library that I have created. So yeah, please feel free to just take a look at that. But to the minimal API, there are some downsides. For instance, you cannot use filters in a minimal API. They are simply not supported. So the problem is that filters are, from my point of view, a very, very important part of an ASP.NET Core application. And for me, it would be kind of like a deal breaker that I can't use filters there. So that's why we're building a regular API with controllers, but on .NET 6. So not on versions that are previous to that. But however, maybe I guess maybe you got confused from the fact that we only have this Program.cs class. Now, this is not only something for minimal APIs. This is the new startup model in ASP.NET Core 6. So if you create an ASP.NET Core MVC application, you will get exactly the same startup behavior, so only with the program class. If you create a Razor Pages application, you would get exactly the same startup behavior with only this program class. If you would create a Blazor application or a Blazor server application, because in Blazor we just had one class also previously, so in Blazor WebAssembly, that if you would create a Blazor server application right now in .NET 6, you would still get only one startup class, which is the program class. So this new startup model is actually for all type of projects that you would have in ASP.NET Core 6, not only for the minimal API. The main difference, or the main, let's say, part of the minimal APIs is that you don't have all this opinionated stuff regarding controllers. You can just get started, define your endpoint, and that's it. However, also another downside of this is that it's actually a bigger pain to work with Swagger in a minimal API than here. Because in a minimal API, you really have to configure every little detail for your Swagger configuration to work. And still, it wouldn't be enough. In what I have tested, there are still a lot of problems with Swagger when using minimal API. So this is another point. But minimal APIs are definitely something worth taking a look at, because probably in the next versions of .NET they will be improved. And in fact, now I remember, I was even involved in a discussion on GitHub on one of David Fowler's gists on the minimal API, and I was complaining about the fact that, hey, I think that filters are really important. And he was saying something like that, okay, filters right now in the minimal API are not there, and they won't be there, but in .NET 7, there will be something like dynamic middleware that you could actually use instead of filters, that would have something like behavior similar to the filters. Like it would be middleware that would be actually only executed if a request is only for a certain endpoint. So that's something that will probably come in .NET 7. So it's worth getting a look at the minimal API, because I think it's the future of APIs in the .NET ecosystem. But right now, if you would start an API for production, I would still recommend to use a regular approach to the API with controllers. And I hope that that this answered your question. I see that we have more watchers. once again, thank you all for joining, and just feel free to jump into the discussion. If you don't know what to know, just please let me know where are you watching from, because it would be I would really like to get to know you better. Okay, so let's go then back to our code and refactoring to keep our program class clean in this case. So we have this iBuilder register, and what we'll have here is a very simple method as part of the interface. It would be a void one, register services. Okay, for this interface we don't provide an implementation, and this would have a web application builder. Let's call it builder, and everything that we do we will do here on this builder. Okay, and let's have another interface that would be registers for the second part, or what we do on the build app. So basically configure our middleware if you want to add our middleware. Let's create a new interface for that, and we'll call this iWeb application register. Okay, and this iWeb application register will be very similar to actually what we have there. So it will be a public, it will still be void. Let's call this register. So what are we doing here? We are adding basically our middleware to the app pipeline. So maybe register pipeline components. Thing is, we can register also maybe or do some other stuff, not only registering middleware. So that's why I wouldn't like to call this register pipeline middleware, but register pipeline components. And of course, in this case, we should get a web application, and let's call it app. So we are cool with that. What is the problem? It's not a class. Correct. That should be an interface, of course. Good. So I'm glad, Amir, that you're watching and that you find this useful. Thank you very much for being a part of the community. Okay, so let's go then one step further. We have these interfaces. Now let's start to create some registers. And the idea is let's take a look here at what we have. We have here things like add controllers. I would consider this functionality that kind of like belongs to this whole MVC concept. But we also have, for instance, add API versioning that kind of like also belongs to the MVC concept. Add version to API Explorer is the same. Then we have the Swagger configurations. I would say that's conceptually different. So maybe we just create two registers for now. But the idea is that it's actually quite simple. We will probably also add at a certain point our data access code here, like the DB context, or maybe when we will use Dapper. So we will then create a register, for instance, for the data access. And then we will just add the services that we use for data access there. We'll also use probably, we'll surely use the mediator package. And we'll probably with the time use also pipeline behaviors and also notifications there. So we will probably have also to do a bunch of registrations. So we will create a mediator register. So you see that the concept is that for each, let's say, logical grouping of services that you would like to add, we just create a register. So in this case, we just split big files in very small files that contain few lines of code, like 5 or 10 lines of code, and that would be it. And that's actually very easy to follow. And then if we have this mechanism to really automatically register new registers, that is actually also great, because we have to just write this once. Then no matter how many such registers do we add when we start up the application, they will be automatically added. And I guess that's a fairly cool part of it, because it could be applied to really any type of ASP.NET Core project, and it would really help you a lot of keeping things very clean. Okay, so I see here right now two concerns. This concern for that it's basically MVC functionality, and I see this Swagger. So let's add then here in register a new class, and this class would be, let's call it Swagger register. Okay, and this Swagger register would implement web application builder register, because that's what we want to implement here. So let's implement the interface. And what we'll actually do here is just move everything that's related to Swagger. We'll actually move here in this register. So let's simply go here, and we have actually these 2 points. No, actually these two. But probably we'll have more at some point when we'll also add security to Swagger and things like that. So that's why I kind of like this idea of extracting this in a register. So yeah, instead of throwing an exception, the only thing that we need to do is simply just do that, and it should work. Of course, we would need to actually add this configure Swagger options. Okay, that would be cool. Okay, so yeah, then if we look at our program class, we have all this other stuff that we have here. Don't give me these hints, which are basically things that concern the MVC functionality. So let's create a new register here, add new class. Let's call this MVC register, and that would also implement web application builder register. And let's implement the interface. And the only thing that we would need to do here is simply take everything that we have here and move it in that file. So that's quite cool, because where is it here? MVC register. Already our Program.cs class is very thin. Okay, we have to add here a bunch of usings, of course. ASP.NET Core MVC and Microsoft ASP.NET Core MVC versioning. So I guess we should be good to go right now. Let me just grab one other drink. Okay, cool. Now let's build this other type of registers. And here, if we go in our program file, in this part, so after we build this app, we still have these two things like Swagger things, and then regular MVC stuff until the run. So we'll create already two registers also for that. We'll have a class, and let's call it Swagger web app register, because, well, we have to name them differently, not have that's with the same name. And this one would implement web application register, because here we add the middleware that we need, and just implement the interface. And what we can actually do here is go to the program. What I would like to do is actually not have this inside only if the environment is in development. I would have my Swagger documentation even if it's public. So let's go to the Swagger web app register and just move all the stuff regarding Swagger here. Okay, now some usings, of course, this one, and I guess we would be good to go with this. And then we'll have another register. Where is it? Add class, and this would be MVC web app register. Okay, but yeah, I have, let's rename that MVC. Yeah, I want to rename this everywhere. Cool. Let me check the chat once again. I see there are no other questions. So for those of you who are still watching here and didn't get involved, once again, Don't be shy. Just let me know as a beginning from where you are watching. That would be already very, very great, and I would totally appreciate that. Okay, so this one would also implement the web application register. So let's implement the interface. So let's go to the program part here, and well, actually we don't need this at all anymore. So what we will do here is just take this out, and actually where is it? MVC web app register, we move that here. So you see actually how clean our program class is already. We just have 3 lines of code, so we can get rid of all these usings, of course, and that's it. We have already our basic application. Now there is one other thing that we need to do, and this is make sure that we actually when the application starts up, we should make sure that we can actually register the services and also add the pipeline components. So in this case, we will just create an extension class for registrar. So let's go here, add new folder. Let's call this extensions. And in this folder, okay, in this folder, let's add a new class here that would be called something like registrar extensions. For now, I guess we will have only 2 of them, one for the web application builder and one for the web application, so 2 extension methods. So let's actually add them. So it would be a public static void. Let's call this register services, and this would be an extension method on the web application builder. This web application builder, let's call this builder. And why we do this extension method on the builder itself? Because as said, on the builder we have ways to actually tweak the configuration. So if we want to read additional JSON files, for instance, so users that might want to register services, they might also want to have access to the configuration, or maybe they would need to also have access to the logging part or to the web host part, because they would need to get information about the web host when they are registering services. So this is instead of having then an extension method on the iService collection, we have an extension method on the whole web application builder. So consumer could use in their registers whatever parts of the builder they need actually to register their services. So this is the reason why we add this extension directly on the register. And then we would have another one, public static void. Let's call it register pipeline components. And this would be an extension method on the web application itself. So this web application app. Cool. So we have that. Now, what we have to do in those methods, actually, it's quite easy. We just have to use a little bit of reflection. And actually, what I want to get here, I would like to, because maybe, I don't know, maybe somebody would kind of like not place these registers directly in the API. They might place it maybe in a different layer, maybe in the application layer or in some other layer. Because if an application gets actually very big, you can actually split it in well, several different projects. If you can extract some functionality that has a common logical part to it, then you could definitely have it. So I want this actually to be able to actually, consumers should provide a scanning assembly for that, and we can then register or use all the registers in that assembly. It's quite of like the way that Automapper does it, the way that Mediator does it, the way that Fluent Validation does it. You always have to provide a type which would be something like a scanning type, or the assembly in which actually those services will scan for certain classes. So let's also have here a type. Let's call it scanning type, and we'll also have this here type scanning type. Okay, so I guess we should be good with that. Let's also take a look in the chat, but there's nothing new. Probably you also got tired a little bit, but yeah, I really want to finish this refactoring, and then I guess we will call it a day. But I want to have a clean file at the end. Okay, so once again, what we have to do here is, well, we can have here var registers, because we want to scan for registers, and then we can use reflection, and we can use the scanning type, and we can do something like that. We want to get the assembly from which this scanning type belongs. Then we want to get all types from that specific assembly. But then we just want to do a filter. So where, and here we would specify some conditions. And here, let's say it's type. Okay, what's not okay for you? What don't you like? So we provide a key for type. Okay, get types. Let's get types, sorry. Okay, because we want to get several. So, and we want to get the type. So we want to do some filtering here. This will just return enumerable, so it really won't load everything into memory. It's, well, just an enumerator. Okay, so then we will have to say that we want that T, the type should be, is assignable to. So the type that we can assign, in this case, it would be the web application builder. How did we call that? web application builder register. Okay, and why we don't have here, okay, API registers, so we should be good to go with that one. Okay, and then we also want to provide some what's the problem with that? Better, okay, the non-generic method, okay, cannot be used with type arguments. Okay, so we cannot use, okay, okay, sorry, and then we'll surely can use it with type of web application builder register. Voila, it go, it's okay like that. So we want to search for this, that where we stop here. Okay, so we want to have that, and we also want to make sure that this type is not the interface itself, and it is also not an abstract class, because we need to be able to build an instance of that. So in that case, we can just say here and T, or the type, is not abstract, and not equal, so type is interface, so it shouldn't be an interface, is interface. Okay, so that's actually everything for our where. Let's go one line below. The next thing that we can do, we can then do a select, and we will select here, we'll use the activator from generics, and we'll say here create instance. Okay, cool. And then we, last but not least, we want to cast it to an web application builder register, so that we can execute that that method. So we have here the cast, and we can specify that we want to cast it to an web application builder register. So yeah, that would be it. This would give us an enumerable of web application builder register. So that's kind of cool, because right now, as we have an enumerable, we can do a for each here, and we can say for each, for instance, registrar in registrars. Okay. So for each of them, we just want to call this method. Sorry, not this one, but this one. We just call the register services. Okay, and we have to specify the builder. We have to pass in the builder. Okay, cool. So we are cool with that. And here we should do exactly or more or less the same thing. But we will have to cast everything to a web application register. And actually, that would be kind of like code repetition. So the only thing that would be different here in this one, or in this part, would be that we would have to provide a different interface here. So I guess it's... we can extract this in a private generic method. So it would be private static. It would be enumerable return an enumerable of t, and let's call it get registers of t, of course, because we have to specify, know exactly for which we want, for which types we actually want to have that. Okay, and then you know what I'm thinking right now? I'm thinking that I would like to use type constraints, but what I am using here are actually two interfaces, and I can't really use OR expressions when doing a type constraint. But in the end, both the web application register and the iWeb application builder register, well, they are registers. So let's use a marker interface for that. Let's use a marker interface. We'll call this iRegister. And as this is a marker interface, we just use it to mark objects with this specific type. And then if we go to iWeb application register, we would say we'll mark it with the marker interface. So that should be cool. Okay, what's the problem with you? Okay, it's just slow. Visual Studio is just slow. And if we go here to the web application register, we mark this also with an I register. Okay, and right now, if we go back here to our extension, we can say here where I register. So now we have a generic type constraint, which is actually very, very nice. And we can use then the T here everywhere in our expression. So let's just copy this. Not really type everything once again. And we will actually, we also need a scanning type here. Type. Scanning type. Okay. And here we will have this only its type of T. Cool. And here we will cast off it also to a type of T. So that's quite cool, I guess. Okay. And what is the problem right now? Oh, we actually don't return it. So, you know, we don't need this variable. We just return that. And voila, that should be go. That should be good. So we have here then registers, and we can say here get register, and we say that I want a register that for the type iWeb application register here, and that will be okay, and specify the scanning type here. Okay, that would be cool. So now we have an enumerable, so we can use the for each loop. And by the way, if you're not 100% familiar with the enumerable, I have a video on this channel where we go really in depth about what an enumerable is and why it's actually very, very useful. And I also use there some very, very practical examples when, for example, reading a file. What's the difference of having the lines as a list or as an enumerable? So you might just want to go there and check that video, because I think that might be useful. If you're not, 100% about what an enumerable is and what it actually behaves and why it's actually very, very useful, then just let's take a look at the video. Of course, after this stream ends, which will be in fairly short time. So for each register in registers, we just want to say register dot here. Once again, not the equals, but the register pipeline components, and we just have to pass in the app, and that would do it. Okay, so we just really need to actually rethink also this one. So our registers would be get registers, only that in this case we want the registers to be of type I web application builder register, and we pass in the builder, the scanning type, sorry. Cool, and everything should work as expected. Now, really the last step that we would have to do right now is go back here in our program class, and we would just have to add these 2 lines of code. So first one, we would have builder, and then on this builder, how did we call this method? Oh, I already forgot it. Register services, and we just have to specify the type. So yeah, let's go back to program builder.register services. In this case, we have our registers in the same assembly. So we'll specify the type of, you just have to specify a type of class or even an interface that is part of this assembly. And then the scanning will be done within this CWK social.api assembly. So just to keep things well clear, we just provide a program class, because even if we don't have it here because it's using top level statements, this class still does exist under the hood. So it's not something that is gone, it still exists, but it's actually hidden from us, it's abstracted away. So we have this register services, and in a similar way, builder.register pipeline components, but it's not builder. Oh my god, here's the app. Here we're using this on the app, and we'll also have to specify type of program, because here is the assembly where we will have everything. Now the cool thing is that no matter how many middleware you will use, if you are using registers, and no matter how many services you will use, your program file will always be like that. So no matter how much your application grows, your Program.cs class will stay exactly the same like it is right now. Of course, you would get more files with registers, but the plus of this approach is that you have only a few lines of code in each register, and it's way more readable from my point of view. Cool, and we can even go one step further. Let's use another feature of .NET 6 and C# 10, which is the global usings. So we right click on the project, we add a new class, and let's call this global usings. By the way, you can name this class whatever you want, so you don't have to name it global usings, and you don't ever need to do anything here. Just specify global and using, and that's actually it. Right now you can virtually extract all the usings that you have a lot in your application or in this assembly in a global using, and then you just don't need to add them anymore. You see that everything is still working. So now I guess it's the big time. It's the big time right now. Let's run the application again, and after all this refactoring, where we have this very, very clean and thin Program.cs file, functionality of the application should be exactly the same. So the first thing is that, well, it started, so we are sure that it should work, but let's also try it out. So let's try out first v1, hello world, so we know that it's v1. Let's also switch over to v2 now. And yeah, let's try it out, provide the ID and execute, and it's hello universe, so it's definitely the v2 controller. And voila, that's basically it. So actually this was a quite long stream, but I guess we have covered a lot of ground. because we have talked a lot about CQRS right in the beginning. We have also talked quite a bit about clean architecture. And then we have started coding and we have implemented versioning of the API, which is really a must when you start a new API for, let's say, production use, because sooner or later you will need to work with different versions, and it's better to really start this from the skeleton of the API to already have these versions built in. And then we have actually versioning the API is actually the easy part. It's quite easy, as we have seen. But making the versioning work with Swagger, well, that was a little bit more complicated. So we needed to add basically a new package, new configurations, and we even had to use the options pattern to configure the Swagger services that the way that we actually want. In this case, we just wanted to configure a Swagger document for each version of the API. So this is why we actually use this options pattern. And then last but not least, we have seen that our program file grew a lot just by adding very, very basic functionality. You can imagine how much it would grow with time when we add a lot of new services here. So kind of we have already planned for that. And we have introduced this concept of registers. And we even have this extension method that actually use reflection to scan a provided assembly for all registers, and then simply execute the methods to either register the pipeline components, so the middleware, or either register the services, which is fairly cool because right now, every time you start up the application, it will do the scan. So if you add a new register, it would automatically detect it and add your services or your custom middleware. And yeah, I guess that's basically it. Probably the next time, which I really can't say exactly when it will be. That's why if you want to keep in touch, please subscribe to this channel to get notified. I usually publish the streams some hours before, maybe one day before it will really happen. So if you haven't done this already, then please just subscribe to this channel and also maybe hit the notification bell button to really have everything okay. And yeah, I guess that's something that would be also important. Also, before we go, once again, I just want to say that if you still want to support this channel, one way you can support this is using the super chat. It's right below the chat text box, and you can just simply say a thank you by making a donation. Another way to support this channel, of course, is if you think it is useful, then please just share the content, share the videos that you like, invite your friends to subscribe to this channel, and I hope that the community will grow more and more. That would be really, really awesome. Okay, so I guess that's pretty much it for today. Thank you very, very much for watching and standing by for so long. And until the next time we meet here virtually, I wish you the very best. Take care, and yeah, see you soon. Bye.